Good morning, Pure Maths 3 class. We're moving now on to the integration chapter, or our first integration chapter from the textbook, chapter 5. And today we're looking at integration of e to the ax plus b, functions of that type. So just a refresher, what happens if we wanted to differentiate this function here? We would say dy dx equals minus 3 multiplied by 5e to the 5x plus 3, or minus 15 e to the 5x plus 3. So that would be our final answer. So integration of functions like that is the opposite of differentiation. So the rule in this case is going to be, if you're integrating e to the ax plus b dx, is going to be 1 over a multiplied by e to the ax plus b plus c. Don't forget your plus c. Okay, and we're going to try a number of different types today. We're going to look at indefinite integrals. That's where we don't have a set range, an upper and lower limit. Definite, where we've got a range, so here we're integrating between 0 and 2. And improper integrals as well, where one of the ends of our range is going to provide us with something that's undefined. Okay, so let's go ahead and try these. So the first one I'm going to do for you today is 1d, the integral of e to the pi x plus 3. So that is going to be equal to 1 over pi, using this rule here, times e to the pi x plus 3 plus a constant. Now hopefully that makes sense, but if you think about it, if we tried to reverse this process by differentiation, if we differentiated this, we differentiate this bit here, which will give us pi. We multiply it by the coefficient of the e, which is 1 over pi, so that becomes 1. And then it will be e to the same power again. So, and the constant will drop out. So yeah, we're right. Let's try 1i. My first step here would be to rewrite this as e to the power of 1 minus x times a half dx. And again, oh, sorry, I should have had my equal sign here, equals that, equals e to the power of 1/2 minus a half x dx. And now hopefully we're in a position to solve this. Let's, how are we going to get a minus half here? So we're going to put 1 over a in this case is minus a half, so it's going to be 1 over minus 1/2 e to the power of 1/2 minus 1/2 x plus c. Now what's 1 divided by minus 1/2? That's simply minus 2e to the half minus a half x plus c, and we could leave it like that. Okay, moving right along, we'll have a look at 2f. Now we're working with some definite integrals. So next line, we're going to put in our square brackets, and this will be 2 multiplied by 1 over 4 times e to the 4x, and we're doing this between 0 and 2. Now this 2 times 1/4 is just simply going to be 1/2, so it's going to be 1/2 times e to the 8, 4 times 2, minus 1/2 e to the power of 4 times 0 is 0. Now that ends up being, I'm running out of room here, that's going to be e to the power of 0 is 1, so it'll be 1/2 e to the 8 minus, and I will just pop that in there. Or you could perhaps factorise as well, but that will be our final answer there. Okay, let's move down to this one here. Okay, this one, we'll use our log rules to help us solve this. So, our first step will be to pop in our big brackets. We're going between 0 and 4. So this will be 4 times 1 over 4 e to the 4x, close our bracket. We don't need a plus c because we're dealing with definite integrals, remember from Pure Maths 1. 0 ln 3. Now when we simplify this, that's just going to be 1, isn't it? 4 times 1/4. E to the power of 4x is just going to be e to the power of 4 times ln 3. And then we're going to subtract from that e to the power of 0. Now, what is this? Well, another way of writing it is to go e to the power of ln 3, 4. Why am I doing that? Because I'm now going to use my log rules. Remember that this ln is going to cancel out that e. E to the ln 3 is simply 3, and that will be to the power of 4. If you've forgotten how to do this, you probably want to go back and have a look at your logarithms chapter. I think that's chapter 2 of your textbook. So this will be 3 to the power of 4, and e to the 0 is 1. Now 3 to the power of 4 is 81, and 81 subtract 1 is simply 80. Probably the key thing for you here is to remember how to do this. Okay? And this rule here, e to the ln. Remember, ln is log base e. So this is one of the rules that we talked about, how this will cancel out. Okay, think about that. Go back if you are unsure. Next one, here, this is number 7. It starts off with something fairly simple. We've got to first say what this will equal. So it will be simply minus 1 over 1, so just minus 1. And we probably put our big brackets around here. E to the minus x, and we're going from 0 to k. And so simply this will be minus e to the minus k minus e to the minus 0, or to the 0. And simply this is going to become a positive 1, so I'm going to put that first, minus e to the minus k. I've just switched these around. Hopefully that makes sense. Now, with this one here, we're simply going to go and use what we've done here. Because it's the same, we've just now got different limits. K is infinity. So, we will say at this point that this is equal to 1 minus the limit as k approaches infinity of e to the minus k. That's the formal way that we write it. We learnt about this, I think, in Pure Maths 1. And that is 1 minus. Now, as k approaches infinity, this number here is a negative, very big number. And if you think about what you know about the e equation, it's going to be almost 0. So 1 take away 0, which is equal to 1. And that's how we solve that. Now, I hope that's a good introduction to you for the exercise. You may need to go back and have a look at how you find the volume. I think in number 9 you'll need to find the volume of a solid obtained when you rotate a function around the x-axis. So you might want to have a look at how to do that from Pure Maths 1. I may even do a video on that if I get time a little bit later on today. But this should be enough to get you started on the exercise. Good luck. I hope it goes well.